In Lesson 3.5, you will be identifying arithmetic sequences, and you will also be finding the nth term in an arithmetic sequence. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. For example, 3, 5, 7, 9, 11 is an arithmetic sequence with a common difference of 2 because it's going up by 2 each time as we go to the next number in the sequence. 33, 29, 25, 21, 17 is also an arithmetic sequence because it's going down by 4 every time we move to the next number in the sequence. So the common difference in that arithmetic sequence is -4. So if it goes up, it's positive. If it goes down, the common difference is negative. In the first example, you're going to be just looking to see if it's an arithmetic sequence. And if it is, you're going to explain by giving the common difference. Or if it's not, you will show that it's not because it doesn't have a common difference. So in our first example, to go from -4 to -2, that's increasing by 2. And from -2 to 0 is increasing by 2. And from 0 to 2 is increasing by 2. Since there is a common difference of 2, this is an arithmetic sequence. So yes, and I'm going to just say the common difference is common difference is 2. Our next example is a little bit trickier because we have fractions. 1/2, 5/8, 3/4, 13/16. If I want to know how much it is increasing or decreasing by from going from 1/2 to 5/8, you can do 5/8 minus 1/2. Or you could think of this 1/2 as 4/8, and to go from 4/8 to 5/8, it increases by 1/8. And then from 5/8 to 3/8, 3/8 is the same thing as 6/8. I'm sorry, 3/4 is the same thing as 6/8. So from 5/8 to 6/8, it increased by 1/8 again. Now from 3/4 to 13/16. To go from 3/4 to 13/16, 3/4 is the same thing as 12/16. So 12/16 to 13/16, it's increasing by 1/16. So this one right here is not an arithmetic sequence. It's not an arithmetic sequence because it doesn't have a common difference. It isn't increasing or decreasing by the same amount. You may want to pause the video and try the next two on your own. To go from -26 to -22, it's increasing by 4. From -22 to -18, it's increasing by 4. And from -18 to -14, it's increasing by 4. So this one is yes, the common difference is 4. Now from 1 to 4, it's increasing by 3. And from 4 to 9, it's increasing by 5. I don't have to even look any further. I already know it isn't a common difference, so therefore it's not an arithmetic sequence. In example 2, we're going to find the next 3 terms in an arithmetic sequence. So we need to see what it's changing by. To go from 15 to 9, it's going down by 6. And then from 9 to 3, it's going down by 6. And from 3 to -3, it's going down by 6. So to get to the next 3 terms, we want to go down 6 from -3, which is going to get us to -9. And then down 6 more is going to be -15. And then down 6 more is going to be negative 21. You can pause the video and try the next one on your own. From 9.5 to 11, that went up by 1.5. And from 11 to 12.5, that went up by 1.5. It keeps going up by 1.5. That's our common difference. So the next three terms, 1.5 up from 14 is 15.5. Up 1.5 more would bring us to 17. And then up 1.5 more would be 18.5. And we have to go one more since it says the next four terms. So the next one up from that would be 20. Now to find the next couple terms is pretty easy. You just add or subtract to get to the next one. But if I asked you to find the 100th term, that would take a long time to write out the first 100 terms. So we have a formula that helps us find the nth term of an arithmetic sequence. So it's the nth term of an arithmetic sequence with first term a sub 1 and common difference d is given by a sub n equals a sub 1 plus the quantity n minus 1 times d, where n is a positive integer. So if we want to find the nth term of this sequence, the nth term is going to equal a sub 1, which is the first term, plus n minus 1 times the common difference. Now to go from negative 12 to negative 8, and then negative 8 to negative 4, and then negative 4 to 0, it's increasing by 4, so the common difference is 4. Now if we want to go ahead and simplify this, a sub n is going to equal negative 12, and then here we'd have to do distributive property, 4 times n, so it's going to be plus 4n, and then 4 times negative 1. 4 times negative 1 is negative 4. Then we can go ahead and simplify this by combining like terms. The negative 12 and the negative 4 we're going to put together as one number. And this 4n we're going to leave by itself, and we're going to put that term first actually, because the variable term goes before the constant term. Negative 12 plus a negative 4 is negative 16. So a sub n is going to equal 4 times the number of the term you're looking for minus 16. I'm going to show you a little hint or shortcut of how to go from the sequence to this right away without going through this whole process. Notice this right here is your common difference. And this number right here is what I like to call the zero term. This is the first term. This is the second term, third term, and fourth term. This right here, the one that would come before it, the zero term, if I was adding 4, if I want to go backwards to the one that came before it, I would subtract 4 from negative 12 and I get negative 16. Notice that number that would come before the first term is what goes right here. And since it was negative, it's minus 16. And again, the common difference, or what you are changing it by each time, is what goes in front of n. Now we can use this right here to help us find the nth term, or in this case, the ninth term. for part B. To find the ninth term, we're going to plug in 9 here. 4 times 9, take away 16. 4 times 9 is 30. 4 times 9 is 36. And then 36 take away 16 is 20. So a sub 9, or the ninth term, is equal to 20. Now the next example I already have worked out for you. It says to graph the first 5 terms of the sequence. Well, the first term we already knew was -12. The second one was -8. The third one was -4. The fourth one was 0. And the fifth one, if we were to keep going or plugging it into this formula, 4 times 5 is 20, and 20 take away 16 is 4. You would have to graph it right like this. First term is -12, second term -8, third term -4, fourth term 0, fifth term is 4. Notice that they fall in a straight line. It's in a straight line because there's a common difference. It's increasing or decreasing by the same amount. Now the last example, which term of the sequence is 32? Well, if I want to know which one is 32, in place of a sub n, I'm going to put 32. And then remember, this was what we came up with. It's 4n minus 16. So we want to know when that's going to equal 32. So you're going to add 16 to both sides. So we're going to have 48 equals 4n. And then you're going to want to divide both sides by 4. I'm kind of running out of room here. 48 divided by 4 is 12. So the 12th term is 32. Now you may want to pause the video and try the next one on your own. I'm going to go ahead and use the shortcut way of coming up with the equation for the nth term. A sub n is going to equal, now we want to look at how much it is changing by, or the common difference, from 3 to -10, and then -10 to -23. It's going down by 13. So that's what it's changing by. That's what goes in front of n. And then the second piece that we need is if we went to the term before the first term. So to figure out what number would be right here, instead of subtracting 13, we would add 13, which means this number would be 16. The 0 term is 16. So there's our equation. Now if we want to find the 15th term, a sub 15 is equal to a -13 times 15 plus 16. -13 times 15, that's going to be -195 plus 16. Since they're different signs, I'm actually going to subtract those, and I get -179. So the 15th term is equal to 179. Now, if I wanted to graph the first 5 terms, I'm going to go ahead and count by ones on my x-axis. And on my y-axis, since these numbers are fairly large, I'm going to go ahead and probably count by tens. So the first term was 3. So the first term is 3. It's going to be, let me get a different color. It's going to be just a little bit above the x-axis. And then the second term is -10, so that's going to be right there. The third term is -23, so it's going to be a little bit past -20. And then the fourth term is -36. -10, 20, 30, -36 is about right there. And we're supposed to do the first 5, so the next one after -36, we'd want to take away 13 more, so that'd be at -49. So the fifth term is at -49. These 5 points should fall in a straight line. Now, if I want to know which term of the sequence is -114, you'd want to do -114 equals, go back up here, here's our equation, -13n plus 16. And then you'd go through and solve that for n. But we're going to just keep moving on because you aren't going to have to do that part on your homework. The last example, Marisol is mailing invitations to her quinceanera. The arithmetic sequence, 42 cents, 84 cents, $1.26, and $1.68 represent the cost of postage. Write a function to represent this sequence. Well, a sub n, or actually, since they asked for a function, we're going to say f of n is going to equal, and we want to look at what it's changing by, because that's the number that's going to go before n. It's changing by 42 cents. So 42 cents times n, plus we want to go back to what would be in front of the first term. What would come before this would be 0, so it's just plus 0. And since it's plus 0, we don't even need to write that down. So f of n equals 42 cents times n is our function. Now graph the function and determine the domain. If we wanted to graph this, we could just go like this and choose some different numbers. Well, actually, we can go ahead and just go ahead and graph. Our first one is at 42 cents. Let's go ahead and let's just count by ones on our graph. So this would be like $1, and this would be the first term. So the first term is going to be 42 cents, which is going to be a little under half. And then the second one is 84 cents, which is going to be not quite $1. The third one is $1.26, so it's going to be a little over $1. The fourth one is $1.68, so we wanted a little more than 1.5. And those should fall in a straight line. Mine look a little bit off, but they should be in a straight line. The domain, remember, domain is the x values of a function, and it wouldn't make sense to mail half of an invitation, so the domain is going to be like this. It's going to be 0, 1, 2, 3, and then we can just put the this to show that it keeps going like that.